so we can get started with. Thanks, Bryant. Now all entire stage is yours. Please go ahead.
Okay, I'll just give a small intro. Okay. Okay. Hey guys, morning, afternoon, evening, whichever you guys in time zone is in. So guys, we have Brian with us, and a very big thank you for Brian to take it on a Friday evening a session. Thanks, Brian, for that. Brian, guys, just to give a small intro, I think any intro for Bryant is very small, to be honest. The way I saw him on the Power BI Fest when in July, when I saw the presentation, I was very keen for him to come and give it to us on our user group. So Bryant is a Microsoft consultant, and he's been doing management consulting for a long time. And what I've seen it from him, the way he has integrating technologies across the globe with Microsoft, it's amazing. To be honest, I've seen the way he was trying to. He obviously there will be a demo right now in this session also about trading, how you can get those insights from a data and do a better trading part with Neo4j graphs and all this stuff. So guys, the stage is all yours, Brian, for you to start the session. Thanks a lot.
Sounds good. Yeah, let me share my screen here, and we will get started, get set up here. Okay, and I think with that we are good. Okay, so yeah, let me get started. So let me just preface this whole thing by saying the purpose really of this session is to we do a lot of integration work, and so we want to basically show how to use Neo4j to find hidden patterns in data. And then we're going to use Power BI to visualize and explore those patterns, to gain insight. So this is what we call pattern-driven insight. And my contact information is there. And I promise you, if you guys connect with me on LinkedIn or Twitter or whatever, I will absolutely let me know that you attended the session. I'll be happy to follow you back and connect with you. So. With that, probably the first biggest question that everybody always asks is, what in the world is Neo4j and what's a graph database? And so what I'm going to do here is play a really short video that just does a much better job than I can of just explaining what Neo4j is and what graph databases do.
Neo4j is the #1 database for connected data, built from the ground up to leverage not only data, but also data relationships. Neo4j is a native graph database, which makes it critically different from other data stores. But what does native even mean? Neo4j is designed around a simple yet powerful optimization. Each data record or node contains direct pointers to all the nodes that it's connected to. These direct pointers are called relationships. All the information needed to find the next node in a sequence is available in the node itself. The native storage layer is a connected graph. That's what native means. Because of this principle, Neo4j doesn't need to compute the relationships between your data at query time. The connections are already there, stored right in the database. Because of this, queries of densely connected data are orders of magnitude faster. Other databases don't save direct pointers between records. They need to compute connections by searching through a separate data structure called an index. This lookup process, which has to be done repeatedly to find each connection, is extremely expensive and gets exponentially slower as the data size and query complexity grows. This makes them inherently slower than Neo4j for relationship-intensive queries. Over the past decade, Neo4j has made graph databases a key technology powering modern applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Neo4j is used to detect fraud, enhance artificial intelligence, manage supply chains, gain a 360-degree view of data, and much more. Learn more at neo4j.com.
Okay, so that's Neo4j. And so what we're going to go ahead and kind of dive in and get started. And for those of you, I don't know if anybody is in the crowd is interested in the stock market, or if you trade, buy or sell options or stocks or anything like that. But if you do, this is probably going to be of special importance to you, or significance to you, special interest to you. So I do have to say a really quick disclosure that throughout this presentation, I am not in any way, shape, or form offering stock advice. or investment advice or stock tips or anything of that nature. What I am doing instead is basically showing how you can use these technologies in a general way to gain pattern-driven insights. So specifically, what we're doing, what I've done in Neo4j is I've pulled in a daily stock price history through an API from TD Ameritrade, a trading account from them. And so what you see on the left here is a 1 year of price data in a graph of Microsoft. And so, and it's basically each day is a node, and then there's a relationship in between each day, just saying, you know, next day, next day, next day. And each of these relationships have data on them as well, and they capture the price gap that may have happened between the close of one day and the opening of the next day. So there's data on the relationships as well. Now, I'm using a number of graph data science machine learning algorithms in Neo4j. Neo4j has a whole bunch of these. We're specifically using, I think, 3 algorithms in 2 different areas. And primarily what we're doing is we're finding similarity in volume, in stock trading volume between the same stock on different days and between different stocks on the same and different days. And then what we're doing with that similarity is we're basically grouping them into communities or into clusters using some community detection algorithms as well. And what we end up with is a graph that shows how different stocks are related to each other based on volume similarity. So here we're showing that Microsoft on certain days has the same volume or volume similarity to NVIDIA, to Alibaba, to other days on Microsoft, to Facebook, to Disney, Cisco, and others. And then just as a kind of a global view, if you will, we end up with this giant like hairball of relationships where we've got roughly 34 different stocks that I'm analyzing in this demo. And you can see all those relationships is kind of zipping back and forth between there. Those are all the volume similarity relationships. And we're going to use Power BI specifically to visualize some of those relationships and make sense out of them. So before we get started too much, I want to just kind of lay the landscape of where Neo4j and Power BI kind of fit in from the perspective of data insights. So we've got patterns and we've got entities, known patterns and unknown patterns, known entities and unknown entities. And when we know both the entities and the patterns of the data, the schemas are very, very tightly or very definitively defined, then that's really the definition of tabular data. We can do a query and ask for specific fields, and we know exactly how to get that data. It's very defined. It's good for descriptive data and information, descriptive analytics. And then when we know the pattern, but we're not sure which entities fit those patterns, then we're looking at outliers and anomalies. And so this is a situation where we create dashboards or interactive reports, maybe for something like sales quotes, sales quotas or something like that, where we know that certain salespeople might be exceeding their quota, might be outliers, or there might be people that are missing their quotas or missing the mark and that kind of a thing. So that's where that area of analysis and insight comes from. But what happens when we don't know the patterns at all? Well, relational databases have a really hard time unless you know the pattern. And so if we know the entities, in this case, in our example, we're going to be using stock market data, so we know what the data is, but we're not sure about what hidden patterns might exist within the data. This is called pattern discovery, and it's what we're going to be walking through today. Then there's the final piece, which is unknown patterns and unknown entities, where we're not sure what we have, or maybe we're combining a lot of different pieces of information, maybe creating a knowledge graph of 10 or 12 different systems, and we're pulling different things together. We're not sure what's there or how it relates and what patterns might exist. And so we want to do those kind of exploratory things. So as you can imagine, just from my description, that when we know the patterns, we're really squarely in the world of Power BI, that it's really strong in those areas. But when we don't know the patterns, Power BI and relational databases can't really handle that. So we've turned to graph databases, and then specifically several different machine learning algorithms and graph data science algorithms to discover those patterns. So what we've done specifically in this that I'm going to be walking you through is we've done a machine learning algorithm on the stocks that we've identified in there, that I've pulled in, and it's called K nearest neighbor. And what it does is it goes and it creates a new relationship between the stocks, between the pricing history and its nearest neighbor, and it's based on the volume similarity of the volume. And what it does is it determines how similar the volume is and then writes a score and writes it back to the database and stores it in that relationship. And then we take that information and we run a Louvain algorithm, which is also an additional it's a data science and machine learning algorithm that basically goes through and detects communities within those similarities of volume. So it kind of groups and clusters those together in the network. And then it maximizes those score and kind of figures out where each similarity group kind of belongs. We also use one additional one that I don't have on the slide. It's called label propagation, and it's another machine learning algorithm that actually takes the Louvain results and groups them into kind of a higher cluster. So we have kind of a hierarchy of communities, if you will, of these clustered sets of volume. And so what I want to do real fast is show you Neo4j, show you the data really quick so you can see what we're dealing with. And I'm going to just pull up Neo4j. And the first thing I'm going to show you is, well, we do have a lot of the instrument data, which is just, in fact, I clicked on Disney, the Walt Disney Company, and we basically have all of the kind of the standard, market information, the EPS, the gross margins, the PE ratios, all that type of thing, all the fundamental information for a stock or for an equity. And so we've got all of that information in there. And then I'm going to show you this is Microsoft. And again, this is just a partial, like I guess it's the first 25 days of Microsoft price history. And let me zoom in a little bit so you guys can see that clearly. And so what we've got in here for each day of prices, we have the close, the high, the low, the open, and then we have the typical price, the volume, and then a timestamp, and then obviously the ticker symbol. So it's Microsoft. And then in addition, what the algorithms have done is they've created these similarity labels. And then they've also created these volume communities as well. And so we've written those back to each entity. Now, each relationship, like I mentioned before, it just says next period. And you'll notice that it has a price gap. So what this means is that it's showing a price gap of minus $1.02. And so if we look at the first one here, it's January 2nd of 2019. So I have about 2.5 years of data in here. This is the first one. So January 2nd of 2019, and it closed at 101.12. And then the next day, which is the third, it opened at $100.10. So that's a net difference. It dropped overnight. It dropped $1.02 overnight. So that's what's being stored there. So then I'm going to show you the similarity algorithms, and you can kind of see these different clusters here. Let me bump up our number. I'm only showing 25. Let me show 125, and you can kind of see some of these other more clusters and how they start to interact and tie together with each other. And these are just where we've got volume similarity between the same stock on different days or different stock on various days, where we've got these volume similarities. And so then on here we've got this these scores, these volume similarity scores, and that's how it ranks and ties everything together. I'm going to show you a couple of other really fast things. So we can go in and look at, for example, similarities between two particular stocks. So here I'm showing similarities between Apple and Microsoft, or if I wanted to show maybe Facebook, we can show between Facebook and Microsoft, or whatever we want to do. And And it's going to go through and basically plot out and show those relationships there, and show the clusters of different related volume similarity days in the database. So the other thing we can do is go look for a specific date and pull in. And in this case, we've specifically looked for something with a similarity score of 1 for related to Home Depot on a particular date. And so what I'm going to do is, let me see if I can, I got to stretch these out just a little bit so I can actually select the line I'm trying to show you guys. So what I've got here is I've got a similarity of 1.0, similarity score of 1 between Home Depot and Bed Bath and Beyond. Or I'm sorry, this is Beyond Meat. So what that means is that if we look at Beyond Meat, on 12/24/2019, it had a volume, a trade volume that day of 201.6388. And if we look at Home Depot, it also had a volume of 201.6388 on 8/2 of 2021. And so that's what a score of 1 means. And then all the other scores are basically some percentage, 1 being 100%, or it's exactly equal or exactly even. That's what the volume similarity means. And then, of course, we've got the giant hairball that just shows all of the 34 stocks and how they all kind of relate and tie together with volume similarity. And this is what we're going to use in Power BI to make sense of and to look at and start analyzing. So that's Neo4j. So before I go and dive into Power BI and we start working with this, I want to real quickly just cover, there's some differences between how graph databases work and how relational databases work. We all know that relational databases have a little bit of a problem doing many-to-many relationships. And so what I've got here is an example of an employee entity and a department's entity, where those are in the orange. And, you know, an employee works for a department, and maybe over time they might have different roles or different job assignments in that department. So an employee could work for many, you know, with many jobs in that same department, or they could work for many departments and transfer around for many departments within that company. So you've got a one-to-many between employees and departments. And then obviously departments employ many employees, so you're dealing with a many-to-many relationship. So in a relational database, we end up having to create these associative tables, is what they're called, in second or third normal form, and to basically create a one-to-many relationship to them, and that resolves that many-to-many relationship between employees and departments. Well, in graph databases, we don't really have to worry about many-to-many relationships. I mean, graph databases really thrive and handle that quite well. But what happens is we take those associative tables, and those become the relationships within the graph. And then the properties within those associative tables end up becoming properties on that graph for that model. And then, of course, the entities become nodes. So you have nodes and relationships to other nodes, and that's how that works. So in our data, we've done our primary work in Neo4j, and so it's already a graph. So we need to pull out that data from Neo4j into Power BI and make it relational again, okay? And so what we have to do is we have to take those relationships and expand them back out to create that, you know, that associative relationship to satisfy that many-to-many between the two entities. And so that's what our queries do in Power BI and how we're going to kind of model that data, if you will. I'm going to show you the query functions, right? In DAX, you can do a sum and then you know, aggregate that or group that by some other function and that type of thing. Well, Power Query Script actually works the same way. What do we do in Power Query Script? We go through and we create steps. We add these steps. And so we've got a list of additional steps over on the right panel of our screen. And what those steps actually are is those are actually individual functions. And so what we can do is we can actually wrap those steps, because we're wrapping the functions inside there, and we can combine applied steps into a single step to take complicated multi-step queries and pull them in and make them one step. And so, and that's what we're going to walk you guys through how I do that. And so you can understand the query, and then we'll go through and then start working on that. So in this example, what we're going to do is just take something that we're probably all fairly familiar with Power BI, which is creating a date table. And so I'm going to go in and just in Power Query, I'm going to do a list.dates function, which is just going to give me a list of dates. And so it's going to the first step in the query is going to be called source. Right, and on all things in Power BI, the first step is always the source step. But what source really is, it's just a variable that actually is a placeholder for this function. And so for this list.dates, and we're going to pull in like 10 dates from some day. Okay, so then we need to convert this list into a table, and so we do that, and we click the button to turn it into a table, and it adds another step, and it converts it to the table. It does a table.list from, and what's the first parameter in there? The source variable. And so I'll show you how this works kind of interactively, and you'll see it. But basically, what we can do is take the function that source represents and replace it in with source, and then effectively wrap that into a single function, thereby combining one step in Power Query with additional steps. And so we'll go take a look at this. And what this basically allows you to do is create these Power Query reusable templates. And so let me dive in and we'll go into that. So here I'm in Power BI. I'm going to click transform and go into Power Query. And I'm just going to add a new blank query real quick. And what I'm going to do is in Power Query, if you're not sure how to do how to format or what a particular function needs, you can just start typing it. I'm just going to do list.dates. And you can see the IntelliSense kind of pulls that up. And if I just hit enter after I've typed in a valid function, it pulls up the Power Query panel to guide you through how that function works. It gives you some examples down on the bottom of that function and what the output looks like. And it gives you this interactive panel, right, to basically pull in a date here. Actually, let's pick October 1st. And what we want to do is we want to count. We want to generate, say, 10 days, and then it's asking us for a step. How many days in between each thing do you want to add? Do you want to do every other day, every 5 days? Well, we want every single day, every 1 day. Okay, and so I'm going to hit invoke, and what that's going to do is it's going to create a function for me, right? And it created a list starting at October 1st, a list of 10 days. And so what we're going to do now is we obviously need to, well, let's do one thing really quick, and I'll show you how this works. And when I click on the edit bar and I click on the source for this invoked function is query 1. And if I hover over it, it shows me that query 1 is actually this list.dates function. And so real quick, if I go into view my dependencies on here, and I zoom in a little bit here and come over, here's our invoked function. You can see that it's dependent on query 1. Okay, so let's close that out. So let's go. So query 1 is really this list.dates function. So I'm going to copy this list.dates, and I'm going to come back to my invoked function, and I'm going to replace, instead of query 1, I'm going to replace it with what query 1 is. Sorry, I did that right in the middle, which is list.dates of that, and I'm going to hit enter. Okay, didn't seem like it did anything, but I've got the same data. And if I now go back into my not my query, yeah, my query view, my query dependencies, and I zoom into this, you'll see now that these are both independent functions. The query 1, I've disconnected them because now I have a self-contained, query going on. So I don't need query 1 anymore. I can delete it. Okay, I've now got a standalone function. So let's add a couple things here. It's a list. We need it to be a table, so we have to convert it to a table. Okay, and I'm just going to take the defaults. We've got 10 days, and then we want to probably turn it into an actual date field. Okay, so we've now got over on our in our applied steps, we've got our source, we've got converted to table and change type. So if I come into this and I hover over this, I click on here, what you'll see here is if I hover over it, it shows me that source is actually this list.dates function, right? And that's basically just telling you that that's how that's working. And if I go to change data type, Its first, the first thing that it has is converted to table, which is the previous step. And if you hover over it, it shows you that it's a table.fromList function. Okay. So what we're going to do real quickly is I'm going to go into the advanced editor. I'm going to zoom in just a little bit so you guys can see this. And I'm going to just combine several of these, or combine these functions into a single applied step. So how I'm going to do that is I'm going to come right in here at the beginning, right where it says source on this one, the source comma, and then all the other parameters. And I'm going to highlight the table.fromList. I'm going to cut it. And then I'm going to get rid of the text there. I'm going to come up to the very front of this list.dates function, and I'm going to paste that in front of it. So we don't need source anymore because we're literally source is that list.dates function. So I'm going to delete that. So now I have table.fromList and then my list.dates function. We're going to do the exact same thing for this next one where we change the data type. And I'm going to again start right after where it references the previous step and all the way to the beginning of that function. And I'm going to Control X to cut it. And I'm going to delete the text there, the step name, and I'm going to paste this in, and again deleting the name because we don't need that anymore either. We're wrapping it around. So what we've done here is we've wrapped twice, two different functions around that list.dates function. The last thing we need to do is Power Query always requires the last step to be the last variable or the last step accessed. So we just have to make that source to match what our last step was. And I'm going to zoom back out so it quits zooming around everywhere. I'm going to hit OK, and you'll see that our steps over here go away and they turn into one single step. And you'll notice that I've got the exact same data in here. I've got my 10 days. It did everything but in one step. Okay, and if I expand this out, I'm going to just oh, that's somebody coming into the lobby. I see. Sorry. And if I expand this out, then you can see, our functions in there being wrapped around at those different, that function. So let's do one other really quick thing so you can see what I've done with my queries. Is I'm going to go in again. I'll zoom in just so it's a little bit easier to read, and I'm going to just I'm going to give myself 2 spaces. And I'm gonna, what I want to do is let's do something really simple. Instead of having a hard coded in how many days I want this to generate, 10. What I want to do is just supply a variable for how many days that I want to supply or that I want to use. So let's see here. Let me come up here, and I'm going to just do I'm going to do double underscore days equals, and we'll say 30 days. We'll just say 30 days and then a comma. Okay, now what I'm going to do on the top line is I'm going to just do a comment, and I'm going to say enter the number of days to generate. Okay, and that's it. So I need to now replace the 10 with our double underscore days. Okay, and now I'm going to hit done. And what this does is zoom back out here. As you can see in my query, it's created an underscore days. So visually, there's a reference there with like a blank to fill in. Okay, and then my comment ends up being instructions to the user, enter the number of days to generate. So if I go to that step, you'll see that I've got my 30 days in there. And what if I change it to just maybe 5? I'll do 5 days, okay, and hit enter. Okay. Now, if I come back out and look at my last step, which is source, it now changes that. So this is the fundamental mechanism I've used to create these query template. Okay. So let's take a look at that really fast. So what you can see here is that I've got the different variables here, each with instructions of what to do. Enter the URL for Neo4j, enter the database name, Neo4j, the username, also Neo4j, enter they're both Neo4j, and then the password. Password I'm using is stocks, and then enter a cipher query, right? And so this is just a standard cipher query that if I literally copy that and come over into Neo4j and run that query, I'll limit limit it to maybe 100 so we don't pull in everything. And it'll basically then show me the results of that day. So it's just a valid cipher query, right? And then what it does is it brings me to this one single step that basically says, the name of this step says ready to expand rows. So you can see I've got a bunch of records, and all I have to do now is just click on the expansion button. I see all the columns that are coming through from that query. I can pick whatever columns I want or unselect them, and I just hit OK, and voila, I've got all this data coming in from Neo4j. Okay, so let's go back and look at this really quick. I want to walk through the query that I use. Now, to get data out of Neo4j, there's several different ways to do it, but what I wanted to be able to do is to be able to refresh, automatically refresh the data from Power BI Online. And so you can use like ODBC, JDBC, BI connectors that Neo4j provides. There's also some third-party, some free custom connectors available for Power BI. But unfortunately, Microsoft Online doesn't really let you do the use those to refresh data. They're not valid for use online yet. I've heard rumors that they're going to allow custom connectors at some point, but it's not a reality yet. So the only way really if you want to have a report automatically refreshed from Neo4j in the online service, you need to do it through a web API. And so that's what we're doing. So now if you've got the data in Azure, of course, you can just, Web API just works like normal. Now, if you do have your Neo4j server down on premises, then of course you'd need to use the Power BI, the on-prem data connector to do that. So, but here's what we're doing. So we've basically using web contents, which is when you say get data from web in Power Query, it's a web.contents function is what that does. And you can see I've just got all my parameters in here with the double underscores that we just saw. And then the one thing that's unique is that, there's a couple of unique things. The first thing is that Power BI, when you get data from the web, it does a web method called a get method to get the data. It's a kind of a read-only method of the web API, and we need it to do a post method to do a post submission to Neo4j. And the reason for that is Neo4j's API actually allows you to update and insert data using their API. So, and that's what the post method is for. And so, in order to get Power BI to do a post method, you have to supply this special code word called content. So all you do is type in content equals, and then whatever you're trying to actually pass into the API. In this case, we are passing in the cipher query, right, that we're running. The only other thing is that obviously we wouldn't want to pass our username and password in the clear over there, over the wire. And actually Neo4j doesn't allow that. It requires you to use basic authentication or basic auth. And so there's a couple of other functions. We basically have to convert the username and password to binary. And then once it's binary, we convert that binary encoded set of numbers or digits into text so that it can send it through HTTP. And then it also sends the query itself as binary also on this text to binary. So a couple of functions there. And that's essentially how all that works. So let's go back and go into this. And so all I've got to do now with my template is I can literally just right click my template and duplicate it, and then simply go in and give it a different query, right? So here's a query where I want to actually pull out relationships. So for the similar KNN volume, right? I just feed in a script, a Power Query that goes and pulls all these in, and then we can pull in that data, and we get it again in a single output step. And here we have the relationship name, the starting and ending node, and the relationship ID. So that's what I've done with each of these queries. If you look at them, they're all identical up to the Neo4j results piece. I'm pulling in the price history. I'm pulling in the similar, the KNN similar record, and here's our similarity scores right here. I'm pulling in the next period relationship, and here's our price gap. And then our price history, et cetera, as well, with all the high, low, open, close, volume, and all those kind of things. So that's the data set. And so what we end up with, is it's not thank you yet. What we end up with is in Power BI as a data model is we end up with our next period, our price history. I've also got a link over to the instrument, and then our similarity close. And we basically just have a one-to-many relationship between all of those. So let's dive in and go start looking at this data and see what we can do with it. Instead of looking at it directly, go ahead. Is there a question? Okay, I thought I heard something. Instead of looking at it directly in Power BI desktop, I'm going to we're going to look at it on the web version. I've published this out to the web. I think it's just a little cleaner. I can blow it up full screen, and we can see it a little bit easier. So the first thing that we want to do is we want to examine this data in terms of look at the stock data itself and just see if there's interesting areas that we want to study and go look at the volume similarity for. And so here I've got from 2019 up till the other, yesterday, I think, through October, data. And what we're showing here in this chart is all of the highs and the lows. And so it's like the highest highs and the lowest lows. And so what you see here are all the lows that have happened, in this case, for several different stocks or most of the stock market. And what we can see is down here, kind of, what is this, around March 16th of 2020. That's about when COVID hit. Everything took a plunge, right? We had a huge major stock bottom. And so I thought it'd be interesting to go look at that bottom and see if we see any indicators or see any similarities and see if there's any value there. So what I'm going to do is I'm going to click on March 2020 and zoom in a little bit. So this brings us into this time range and we can see things a bit better. Down here on this chart here, I'm just showing the average volume. And then it's color coded by these volume communities that we've created in Neo4j. So the numbers themselves are meaningless. They're just random generated clustered numbers, IDs of numbers, but we can visually then see which things are related. So let's start picking a couple of stocks. So let's start off with, this chart up here, I think handles 5. So we'll do Apple, we'll do Disney, we'll do Facebook, we'll do, of course, Microsoft, and then just maybe NVIDIA. Those are ones that I think most people are fairly much aware of. And you can see as I was clicking those, as I unclick and click them, that these, the color bar charts here, they start showing up between those selected stocks, things that, where I've got similar volume communities that are being shared between these stocks. And so as I'm looking at this, I'm kind of thinking, well, it looks like there seems to be some kind of correlation or different things here, and it's what warrants a little bit more study, right? But we can clearly see that there's something going on, and we seem to have tie-ins here where a lot of different stocks are the 5 that we've selected are all showing up here at various different levels. So let's go a little bit deeper, and let's go into our volume similarity tab. And I've got this zoomed into the same time frame. So March 2nd to April 6th is what I've got up here. And I've got that same kind of chart up here, did a little bit different colors, but the same thing. And then on the bottom, I have our volume similarity score, and then the market day, the day, to kind of correspond with our candlestick chart or stock chart. And then I've got our community volumes and things like that, similarity volumes, and then our similarity scores down here. So we can start kind of looking at different outliers and things like that within the data set. And so just generally looking at, so again, right now we're looking at Microsoft, Apple, Facebook, Disney, and NVIDIA. That's a synchronized slicer that pulled over from the first screen. And we can see that there's several different big spikes here on this volume similarity. And so the first one here is on March 6th, which is right here. So March 6th is a big spike just before it takes collectively a $200 fall, nearly, or $150 fall, whatever that is, to kind of plunge to the bottom. And then we see on April 1st, right here, we see another major spike here with all 5 of these stocks selected that kind of just generally shows this this kind of, it looks like it's a support line right around, you know, this kind of common area right here where it's maybe the fall is over and there's a very strong indicator here that we've got a valid support line to go higher. So let's look at a couple of stocks specifically. In fact, let's do this. Let's look at our outlier. Down here on the bottom, we've got this big green outlier, which is NVIDIA. Okay, and it's a major part of this big spike over here. So let's go and just look at NVIDIA specifically and take a look at that. And so NVIDIA now has, I think, is this the right, yep, I picked the right one there on 4/1. It has this major spike here, and really it's right at the $60 line. You can see that line right there. It's just almost a straight line, and it's a very strong support line where the stock market basically started going up. So it kind of nailed the reinforcement there. Let me get rid of that big giant one for just a second so it kind of scales that down. What I've done here is just shrunk down my volume similarity score to kind of hide some of those giant numbers so I can see some of the smaller ones. And then here we can start clicking, oh, I missed it. This guy right here is a very big spike just before the plunge for NVIDIA. We don't see much at the bottom, a small spike, but not a huge spike. But it's sort of is feeling like this is there might be something here, like it might indicate something. We'll look at one more. We'll look at Microsoft, and we'll look at this this big bottom here, and it looks like there's a giant spike at the very bottom of where Microsoft hit their low point during that time frame. And then again, we kind of see, I forget which one it is here. I picked it. This is where it's basically spiking again, indicating that, hey, kind of reversal. It's kind of validating or verifying a reversal. So so it looks like we've got something, but it'd be nice to actually validate this sort of scientifically, statistically, right? So let's go look at correlations and see if we can see correlations between these things. So here I've got Microsoft selected, and I've got a correlation plot over here, and on this correlation plot, you can kind of see, here's our volume community and our volume similarity on the right and also on the bottom here. And so what we're looking for are things where we've got larger circles of either red or blue showing a positive or a negative correlation. And we do see that for Microsoft, that they're during this, so I've got that time range selected. So for that time range, we see a lot of correlations. So you can see here, hey, Power BI can do graphs too. So here's a graph in Power BI. And what we are looking at here are percentages or the volume similarity between different stocks in Microsoft. And we see that Moderna has a very high set of relationships. So let's click on Moderna, and what we're looking at now is Moderna and Microsoft correlations, and you can see here that we've got huge correlations. For our volume similarity, we've got a perfect -1 match. So it's a perfect negative correlation. We have a positive 0.8 match on our price and our average volume, and those types of things. So we can also go in and look at just generally and pick like Moderna and Microsoft together and see that there's average volume correlations and with our similarity score and our volume communities and those types of things. So we can see that, you know what, statistically there really is something here. This volume similarity really seems to be able to, is actually indicating and showing us something. So let's dive in a little bit further and look at some other information. These are different correlations that I've done in Python. And so I've got just several different views on this one. Python isn't really interactive. You can filter it and things like that, but you can't really click on it and do things with the Python inside of Power BI, at least not yet. But I have got this filtered. So I've got a couple filters out here, and I filtered, I think, Zoom, Adobe, Microsoft, Apple, NVIDIA, and AMD. And so what this is showing us is our scatter, kind of a 3D picture of the scatter plots of these, of the volume communities and the similarity labels. So we can kind of see the top, bottom, left, and right view of the data if we were looking at it in a 3D model, and just kind of see where and how these different things correlate to get together. Here we've got a simple scatter plot, and then which is similar to what I've already shown you. And then here we're looking specifically at the price gaps and the community volumes, and we can see where price gaps and how our price gaps related and correlated to volume similarity, and then we've got a standard thing there. So let's go and look a little bit further at some of these distributions, and this will take just a second here to load. And what I've done here is I've basically gone in and I've applied a filter to these volume similarity labels that I showed on that other screen. And what I've done is I've noticed that there was a bunch of clusters in the kind of on the left-hand side, on the right-hand side, and on the very top and on the very bottom. So what I've done is I've just filtered my similarity labels to show less than 6,000 and greater than 19,000, and then my volume communities less than 6,000 and greater than 15,000. And that kind of splits out these little quadrants maybe of interest where I want to go and look a little bit further. And of course I can go in and do a custom visual on this and add, if I want to see what stocks those are, I can type in my ticker and then convert this into to show basically which color coded. Did I do that right? Oh, there it goes. To basically show color-coded wise what stocks are making up these different clusters. And you can see that it's Alibaba, it's Costco, it's Adobe, you know, it's a bunch of different ones. But so that I can kind of zero in and, you know, even zoom in to a particular area and kind of study it further and expand it and kind of, you know, see it a little clearer and that kind of a thing, zoom in. So basically what I'm doing here is I'm using Power BI to be my analysis, to view the data that I've created, these hidden patterns, and to analyze and discover what's in there and what might be potentially profitable to go and you know, maybe create trading systems and things like that with this data. And so with that, that's pretty much you know, that concludes the presentation. And you know, if you guys well, I guess just a summary. I've kind of shown you guys a quick technique in Power Query to show how to wrap those functions to create single query templates, and then we use Neo4j to go in, and I use machine learning algorithms to create data connections, new connected relationships with the stock price history. We imported that in using that template, that query template, into Power BI, and then we use Power BI as an analysis tool to go in and learn and figure out and discover what data and what might be useful in there to take back and to use to further study and iterate through. So with that, I guess I'll open it up to questions, and I'm happy to walk through anything or show you guys anything else you want to see under the covers or that kind of thing. So.
All right. Thank you so much, Bryant, for this wonderful session. So we have few questions here. So let me just go through the question one by one. So the first question here is for Neo.js, is there any licensing model to be applied? Like if we want to make any calls, is there any specific licensing model that we need to follow, or is it something which is open source? That is the first question over here.
Yeah. In terms of for Neo4j, there's no licensing that's required to make the API call. Now, Neo4j itself so I'm using the enterprise version of Neo4j, which does cost. But there are free there's free community versions that are eternally free, but you can't really necessarily do all the graph analytics and the machine learning algorithms directly in there. You can't. It comes. You can license that as part of the enterprise package, but you can download Neo4j Desktop, which gives you a desktop version for free of the enterprise version, which is what I was using. And so you're welcome to do that. In fact, Neo4j encourages you to use that. And then once you get ready to actually do something into production, then obviously you need the server and you need to license that. So that part does cost, yes.
Yes,
But
thanks.
Brent, I wanted to ask you this question for a long time. The desktop version, does it has all the features that that are part of enterprise, or does enterprise has much better? Because like
No, it has everything. Yeah, in fact, it is when you just go to neo4j.com and download the Neo4j desktop, it's the full enterprise version. What it doesn't let you do is you can't connect multiple computers to it. That's basically the only thing you can't do. So it's kind of a single computer, single person use only. So you can't just like fire it up on your desktop and then like have it be your enterprise. They don't let other computers connect to it. That's about the only restriction that you have.
Mm-hmm. Got it. Okay. Now, second question here is like, let's say, as you mentioned, the refresh procedure for this particular report. Like, basically, in Power BI Desktop, we need to refresh and publish because in service, not even a limited sort of connected support. So, what do you recommend, Bryant, here, like for scheduling the refresh for this kind of report? What
Yeah.
should be the best approach?
Yeah, and again, just to reiterate or to clarify what I mentioned earlier, is there's a lot of different ways to get data from Neo4j into Power BI. The queries that I've shared with you, and by the way, all of those queries are available. I have a GitHub, several gists out on GitHub, so you can go visit that, or you can go to Medium, and I actually have an article that has all of that source code in there, and a working example of how to do that and use those queries to get data from Neo4j into Power Query or into Power BI. And those are all out there, and you can download those for free. It's all open and available for everybody. But specifically, I'm using the web API so that it can do data refreshes. So the connectors and the JDBC, ODBC things, those work only on the desktop, right? You can't put that up you can't put an ODBC connection up on the web to Power BI Online Service. It won't refresh, but the web API does. And so that's why specifically I'm using the web API to connect to Neo4j so that you can refresh it automatically from the web service. So, because that does work.
Okay, sounds good. All right. And another question that we have from YouTube Live is like for the visualization that you have shown in your report, you have used some Python code in order
Yes.
to create that visualization. So which libraries did you use? That is something that people wanted to know.
Absolutely. Yeah. And the Python, I'll show you here in Power BI desktop. The Python is like super dead simple. You can pretty much like go and like, even if you don't know Python, you can do these guys. So you could just like go and do a web search for like these kind of things. So on this one, most of them use Seaborn. And so basically pretty much everything you do in Power BI, you have to do this plot.show, which is part of matplotlib. Let me zoom into that a little bit. So that's matplotlib. And then the other thing I'm using is Seaborn. And so this big fancy pair plot up there with all the colors and all that, that's literally one line of code. You import the two modules, and then you do a pair plot with the data set and tell it what you want to be the
Wow.
colors, and the colors in this case are tickers. So it's and then you do a plot.show. So it's literally, you see that 4 lines of code, and then I've just put in price gap, similarity label, just whatever fields or columns I want, and I get that graph. Okay, very similar on the on the scatter plot. It's a single line of code, again using Seaborn and Matplotlib, and it's just a couple of formatting things and telling it what you want to do for colors, and you just fill in that one. It's literally one line of Python. The one with the price gap, I had to do a little bit more formatting to get what I was after, and so it's there's just a layout to shrink it down and make it kind of fit better, but it's mostly one line of again Seaborn doing a pair plot, and then I changed some data column names. So it's mostly with some extra lines of code for formatting. It's pretty much one line of code. And then the last one is this is the most complicated actually, which is the correlation plot. But I tell you what, the one and it's using Seaborn, Pandas, NumPy, Matplotlib. Because you have to create a data frame and then do the correlation, and then Seaborn to kind of create the heat map colors and all that stuff. So that one's by far the most complicated. But honestly, what I've done over here with the correlations, this you can just download this right out of the out of App Source. It's just go look for correlation plot and our correlation in the marketplace, and this is an R-based correlation, and it's got a lot of wonderful properties, and you can change how the correlations look. You can change the color. It's like it's wonderful. It's better than you can do in Python actually. So yeah.
All right.
Brian,
Great.
can you have the Power BI file?
Do I have I have a version. I have a version of this. I don't know if it doesn't have exactly this data, but I do have a version of the Power BI file on our website that you can actually download. So if you go to where's this at? Let me flip back over to this. So if you go to do I not have that up here? Just go to right here, internetius.com. Whoops, internetius.com. There's a download section in there,
Okay.
and in there there's a you can I did a similar presentation integrating from Neo4j to Power BI in 2020 for a Neo4j conference, and that Power BI file is available, and it has several of the queries and that kind of thing in there as well, and you're welcome to download that. I haven't made this one available, but that's a good idea. I may do that in the future. So
Okay, thank you.
Sure.
We'll check on that one for sure.
Yes. So today's session is a complete package, like because we have learned so many new things from Neo4j to this visualization to how to consume it to Power BI. So it's a complete Power Pack, presentation. And if I see the analytics from YouTube, so far around 50 plus people has joined us from there, and few people joined from Teams. So that's a really great session, and people also ask a really interesting question. So that's really great. So I think I'm good for the Q&A session. Prince, do you have any other things to bring up here?
No, Brian, but definitely, Brian, will call you back again with another integration,
Sure.
with Power BI for sure. I know you must be something, or your mind must be something, doing something in the back end. So once you are ready, we'll call you back again with another interesting integrating session of, because usually what people know is usually people work with relational databases. If you check Power BI, I think 80% of Power BI runs on a relational databases, kind of a stuff of data. So or maybe unstructured data in a sense of files and all this stuff. But I think this is something new people can go to and make it life their make their life very easy in a sense from a graphical database, because I think graphical database has its own powers in a
Definitely.
sense.
Yeah.
Yeah. So I think
Yeah, it's kind of like the number one graph database and the number one
Yes,
BI tool together. Like, why wouldn't you do that? So,
yeah,
exactly.
totally agree to it. Let's see if we can let's see if in the next year we can call you back in January, February somewhere again with some another interesting session. I know you on Christmas Eve you must have found something very nice for to share with the community.
thank you. And I'd be happy to do that. Yeah.
Yeah. Thank you. Thanks a
Thank,
lot for taking our time out on Friday evening when it's already TGIF. So thanks a lot, Brian, for your time. Thanks, audience, for pitching in and learning by. And Brian will share the YouTube link as well as the recording of the on our on channel, and you can also spread the word from your on your LinkedIn profiles.
Absolutely. So,
thank you so much. Thank you so
Yeah.
much,
thank
Brian,
you
for
guys.
a
I really
wonderful
appreciate it.
session.
It's
Thank you
fun.
guys. Thanks a lot, Brian. Bye.
Bye bye,
Bye,
everyone.
guys.
Bye bye.